My name is Mark Conde. I'm a professor of physics in the Department of Physics in the College of Natural Science and Mathematics here at the University of Alaska Fairbanks, and I have a joint appointment in the Geophysical Institute. We're basically working in collaboration with a large European project, which is called ISCAT 3D, and they're building a next generation ionospheric radar that will produce images of the ionosphere in sort of volumetric images of the ionosphere with high time resolution, high spatial resolution. But that radar only looks at the ionosphere. It doesn't look at the background atmosphere that the ionosphere is embedded in. So we have sent 3 observatories to Scandinavia that sort of surround the ISCAT 3D facility. Each observatory has a set of 5 instruments in it that are mainly focused on looking at the background atmosphere. The ionosphere that the radar is studying is embedded in. Both the Europeans and the American side of this project are interested in studying the upper atmosphere at altitudes above 100 kilometres, up to several hundred kilometres. And those are altitudes where spacecraft operate. Those are altitudes that radio communication passes through that have influence on navigation. And the sorts of things that impact the spacecraft orbits, navigation, communication, are really quite local scale features in the ionosphere. It's not, we've understood for decades the big picture of how the ionosphere and thermosphere behaves, the sort of global scale picture. But now we're sort of zooming in on the small scale features of the ionosphere and thermosphere that just impact radio signals and satellites. It's those small scale features that cause the impact on the signals. So there's really no other facility in the world that can do what this combination of the US and European instruments can do together. Here in Alaska we have instruments that are somewhat similar to the ones we've deployed in Europe, but we don't have the ISCAT 3D radar facility. So it's the combination of those 2 state-of-the-art facilities looking at the same volume of atmosphere that really makes this special. Once we have the combination of this tri-static array of observatories working in conjunction with the ISCAT 3D facility, that combination of remote sensing capability is really going to be unique and will allow us to zoom in on what's happening in the ionosphere and in the atmosphere as it's being perturbed by the aurora, and we've not been able to do that before. It's very satisfying to be able to build the best version of these instruments that we can, house them in nice, professional, well-supported environments, to collaborate with enthusiastic partners in Europe. We have a lot of partners in Europe who are very keen to see these data and to work with us. And just the locations themselves are exciting places to go and to work. So for all those reasons, we're tackling questions that matter. We're using instruments that provide the best data possible to do that. We have active and vibrant collaborations with colleagues, and we're doing it in an exciting part of the world. So it's one of the best projects I've worked on.